Welcome to our notes for our second worksheet on 5.1. First thing you're going to need to know for this worksheet, we're going to dive right in, is what is the Pythagorean theorem? Well, first, Pythagorean theorem is for right triangles only. All right, now we need to know the parts of the right triangles. The sides that make up the 90, we call those the legs. Again, I always write it with the little 90 degree, just like the letter L. So those are the legs. All right, the sides that make up the 90. Then what do we call this other side? Well, this side is the hypotenuse. All right, it's the longest side of the triangle. It's the side that's across from the 90. There's our 90. It's that side that's across. That is the hypotenuse. So Pythagorean theorem, what does it look like? Well, they usually use the letter A and B for the legs, and they use the letter C for the hypotenuse. What's the formula then? Well, it's the leg squared equals the hypotenuse squared. You'll see it written as A squared plus B squared equals the hypotenuse squared, C squared. All right, but remember, again, it's the leg squared always equaling the hypotenuse squared. Okay, some people always want to solve for the unknown. Let's take a quick example of how that works. Here's a right triangle. We know two of the sides. We can find the third side by using the Pythagorean theorem. Well, remember Pythagorean theorem, leg squared equals the hypotenuse squared. So we just say 6 squared plus x squared equals 10 squared. Now it's just a simple algebra problem. 6 squared is 36 plus x squared equals 100. We subtract 36 from each side, subtract 36. So we get x squared equals 64. Now we want x, not x squared, so we have to take the square root. So in this case, x equals 8. That's how the Pythagorean theorem works. There's a quick little example. So here's some problems that you'll see now. AC is the perpendicular bisector to BD. So we know that this is a right triangle. Find AB. Well, if we highlight ABs right here, all right, well, you can see that we've got a little right triangle that's forming right here. And since that's 3, that side's 3. So if we want to find AB, that'd be C of our right triangle, or I could put an X there. So to set it up, we would just say, hey, 3 squared plus 12 squared. Again, those are the legs of that right triangle. Again, here's that, each side's right triangle equals C squared. Solve for C. Just kind of showed you guys how. Now, here's another type they might ask. They might say, is AC a perpendicular bisector? We're not sure. Well, here's how you check. You pick, if it's a perpendicular bisector, we know that we have right triangles, and then we know that these values must work. Pythagorean theorem must work if it's a right triangle. So you just do 3 squared plus 4 squared equals 5 squared. If it works, it is a perpendicular bisector. If it's not equal, then it's not a perpendicular bisector. Okay, you'll see some of those examples on that worksheet. Okay, on to the back side. All right, now this is where we're going to have to use some of our previous formulas. We've got slope, remember y, subtract the y's over the x's, change y over change in x. Midpoint, adding up the x's, divide by 2. So AB is the perpendicular bisector of CD. Find the coordinates of point B. Well, if it's a bisector, well, that means that this segment is congruent to that segment. So that means that B is a midpoint. So we're going to use this formula right here to find B. And remember the midpoint formula. It's just, all right, the midpoint equals, capital M equals, you add the x's together, divide by 2. Well, here's an x, so it's 14 plus 6 divided by 2. That's one of my ordered pairs. And then for the other ordered pair, it's just add the y's together. -4 plus 8 divided by 2. And that's how we figure out our midpoint. All right, so 14 plus 6, that's going to be 20 divided by 2. And then this -4 plus 8 is +4 divided by 2. So 20 divided by 2 is 10. 4 divided by 2 is 2. So that is my midpoint. That is B equals that point right there. Okay, understanding perpendicular bisector and midpoint. Last two I kind of want to check for you guys is AB the perpendicular bisector of CD? Check for perpendicular lines with slope. All right, remember, slope are opposite reciprocals right here. So if I had 2/3, the opposite reciprocal would have to be negative, and then you flip the fraction. So there's an example of what opposite reciprocals look like. So here's what you got to check. You got to find the slope of AB and compare it to the slope of CD. So remember the formula. So it's M equals AB. Here are my two coordinates, A, B. So I just do my y2 minus y1. So I'll call this one my second point, my x2, my y2. So I'm going to go 1 minus a -6, which becomes plus 6, obviously. And then that's over 10 minus 5. So 1 plus 6 is 7. 10 minus 5 is 5. So CD, when I find the slope of CD, we want to make sure that it equals, if it's perpendicular, it's got to be opposite 5 over 7. So you're going to check that. And then to find if it's the midpoint, we're going to add these two together. And I'll show you right here. So not only does that have to be a right triangle, these two added up have to equal this. So you check the midpoint, all right, which we can do right here, let's do the x's first. 12 plus negative 2. 12 plus negative 2 divided by 2. 12 plus negative 2 divided by 2 that's 10 divided by 2 is 5. So that works. And then you want to do the same thing for y. You want to say, hey, is negative 1 plus negative 11 divided by 2, that better equal 6. And if it does, then it is the midpoint. If it doesn't work, then you've got to figure out what part's wrong. Last thing I'll show you guys, TM bisects angle DTE if DT equals 15x minus 10. So this whole DTE, that's this whole thing, equals 15x minus 10. Well, if this inside part right here, if it's bisected, if that's 3x plus 4, well, then this side right here has to be 3x plus 4. So what I like to do is that 15x minus 10 has to equal those two added together because of our angle addition property. 3x plus 4 plus an additional 3x plus 4. At this point, it just becomes an algebra problem. We solve for x. So 15x minus 10 equals, I combine my 3x and my 3x, so that's going to be 6x. And then I combine my 4 and 4, that's going to be plus 8. Then we would just continue to solve until we find x. So when I do that, all right, I'm going to subtract 6x, I'm going to get 9x, all right, minus 10 equals 8. I'm going to add 10. So this becomes 9x equals 18. So x equals 2. Now, once x equals 2, I need to then plug that in for x to find the measures of the angles that they're asking me for. So there's a quick run through on the problems that you're going to see in tonight's in that homework. So